All right, so welcome to this video. We'll be looking at questions on independent events and mutually exclusive events. So we have this question here to help us understand independent events and also mutually exclusive events. Okay, so we'll start with the definition. So when they say two events, A and B, are independent, okay? If events A and B are independent, then this will simply mean that the probability of A intersection B is the same as the product of the probability of A and probability of what? B. So here you can put a multiplication sign if you want. Okay, so this is what it means for two events to be what? To be independent. It just means that the probability of A and B, A intersection B, will be the same as the probability of A multiplied by the probability of what? B. And then when you talk about mutually exclusive events, okay, so I'll just write that as MEE. So if two events A and B are mutually exclusive, then it means that the probability of A intersection B is going to be equals to what? To 0. Okay. The probability of A and B is going to be equals to what? To 0. All right, so those are the definitions that we are going to use here. And then again, on the independent, okay, if two events are independent, it means that the occurrence of one event is not going to affect the occurrence of the other. So it also means that the probability of A, given that the event B has already occurred, is just the same as the probability of A. Okay, because these two events are independent. So meaning the occurrence of event A is not affected by event B. Okay, in the same way or similarly, the probability that the probability of B given A will just be equals to the probability of what? B. So this simply means that, okay, this simply means that the probability of B given that event A has already occurred won't be affected, okay, won't be affected by this event that already occurred. So if two events are independent, then this is the definition there, okay, and it's also important to note these theories there. All right, so now let's look at this question that we've been given here. So the first question, they're saying two events A and B are such that the probability of A is equals to 1 over 4 and the probability of A given B is equals to half, and then the probability of B given A is equals to what? 3. So the first question is, so we are on A. The first question is, are the events A and B independent? Okay. Are the events A and B independent? So we said, by definition, if A and B are independent, then the probability of A intersection B will be the same as the probability of A multiplied by the probability of what? B. We also said the probability of A given B, okay, if these are independent, should be the same as the probability of what? A. We also say the probability of B given A should be the same as the probability of what? B. If all these hold, then we are going to say that the events A and B are independent. Okay, so here we've been given that the probability of A is 1 over 4. Okay, the probability of A is 1 over 4. And then the probability of A given B is actually equals to 1 over 2. And then the probability of B given A, okay, is equals to 2 over 3. Okay, so these probabilities here, like this one and this one, are what we call as conditional probabilities. All right, so are the events A and B independent? We are going to say no. Okay, why? Because I see that the probability of A given B is equals to 1 over 2, which is not equal to the probability of A, which is 1 over 4. Okay, we said if two events are independent, then the probability of A given B should be the same as probability of A. But you can see here that the probability of A was given as 1 over 4, and then the probability of A given B was given as 1 over 2. So it means these two are not equal. Okay, so here, are these events independent? We're going to say what? No. As simple as that. So these theories here are very what? Important. So if you don't know these, you just be wasting time trying to solve and maneuver these things, but you won't go anywhere. Okay, so on part A there, to answer that question, if it's in an exam or a test, you're just going to simply say no. Why? Okay, because probability of A given B is not equal to the probability of what? A, which violates the definition of independent events. All right, so having done that, we've answered part A. Let's answer part B. So part B, they're saying find the probability of A intersection what? B. Okay, so to find the intersection of A intersection B, we are going to use the definition of conditional probability. Okay, so the probability of A given B, when we are talking about conditional probabilities, it's the same as the probability of A intersection what? B divided by the probability of what? A. Oh, divided by the probability of B. So the one that has already occurred is the one that you divide with, which is the B there. So meaning that if it was the probability of B given A, it will be probability of A intersection B, B intersection A, it's the same. So I can still write A intersection B. But down there, I'll write the probability for the event that has already occurred, which is A. So the event that is here is the one that goes to the bottom. So this is the definition of what? A conditional probability. So we're going to use the conditional probability definition to find probability of A intersection B, because here we've been given some conditional probabilities and the probability of what? A. So I'm going to say probability of B given A is actually equals to the probability of A intersection B divided by the probability of what? A. So you use what you have to get what you don't have. So we are looking for this probability. So I'll cross multiply here so that it will be probability of A intersection B is equals to the probability of B given A multiplied by the probability of what? A. So this will just be equals to probability of B given A has already been given there in the question. So that is 2 over 3 multiplied by the probability of A, which is 1 over 4. So this will just be 2 multiplied by 1. That will be 2 divided by 3 multiplied by 4. Okay, so 3 multiplied by 4, that would be, okay, so 3 multiplied by 4, that would be 12. And then I see that 12 can go there and there. So into 2, 1, into the 12, 6. All right, so that's the probability of A intersection B. And I can even write it somewhere here. So I'm going to say this is equals to 1 over 6. Okay, next question. They're saying C, are A and B mutually exclusive events? So we said two events are mutually exclusive if the probability of their intersection is actually 0. But here we see that the probability of A intersection B is equals to 1 over 6, which is not equals to 0. So we're going to say no. Okay, A and B are not mutually exclusive. Okay, so you can finish the word there. All right. Okay, so next is part D. Part D, they're saying find the value of the probability of B. So there we're also going to use the conditional probability. Okay, we're going to use the conditional probability. Okay, so conditional probability that we're going to use there is this probability of A given B. It's the same as the probability of A intersection B. and then divided by the probability of what? B. So I'm focusing on finding this guy. So I can say over 1, cross multiply this and that. It will be probability of B multiplied by the probability of A given B is equals to the probability of A intersection what? B. So meaning that the probability of B will just be equals to probability of A intersection B divided by probability of A given what? B. So this will just be probability of A, okay, intersection B. Is this one that we found here? So that is 1 over 6. So I'll write 1 over 6 and then I have divided by, so I'll write the divided by like this. Probability of A given B, which is this one here. So that is 1 over 2. So this will just be 1 over 6 multiplied by, this one goes on top. This one comes down. So that is 2 over 1. Okay, so this will just be 2 over 6, which will end up being 1 over 3. Okay, so simply saying that D, the probability of B, is actually equals to what? To 1 over 3. Okay, so the probability of B is 1 over 3. All right, let's look at the last one. Okay, so the last one they're saying, okay, the last one there they're saying, find the probability of A union B. Okay, so probability of A union B. This is just the sum of probabilities. Okay, so it's the inclusion exclusion rule that is going to work here. So probability of A union B is the same as probability of A plus probability of B and then minus probability of A intersection B. Okay, so we're trying to remove the thing that we've counted twice. So because when you say probability of A, we're saying everything that is in A. Again, probability of B, we're saying everything that is in B. So those things that are in the intersection between A and B have been counted twice. So we have to remove 1. Okay, so that's why we're saying minus C, A intersection B. So probability of A, okay, was given as 1 over 4 plus probability of B, we found it to be 1 over 3 minus the probability of A intersection B, which is 1 over 6. So just look for the common denominator here. So for 4, 3, and 6, that will be 12. 4 into 12, 3 multiplied by 1, 3 plus 4 into 12, that is 4 multiplied by 1, 4 minus 6 into 12, that is 2 multiplied by 1, that is 2. So that will be 3 plus 4, 7 minus 2, that will be what? 5. And then that will be over 12. Okay, so that will be our final answer. So on E, our answer is going to be probability of A union B is simply equals to 5 over what? Over 12. Okay, simply equals to 5 over 12. All right, so let's look at more questions on this concept. So this is the next question that we'll be looking at. Okay, so the question says, if events A and B are such that the probability of A is equals to 5 over 5 is equals to 2 over 5, and then the probability of B is equals to 1 over 4. Okay, the question is, if A and B are independent events, find the probability of A intersection B. So here we've already been told that A and B are independent. So meaning, okay, part 1 here, which is probability of A intersection B, is just going to be equals to probability of A multiplied by the probability of what? B. Because A and B are independent. So this is going to be equals to probability of A, it's 2 over 5 multiplied by probability of B, which is 1 over 4. So this gives me a 4 over 10. Hey, not 10, but 20. So a 4 over 20, which reduces to 1 over what? 10. Okay, so the probability, can be writing them here. The probability, okay, of A intersection B is actually equals to 1 over 10. Let's look at part 2. Okay, so part 2, they're saying find the probability that the probability of A intersection B complement. All right, so here, how can we find this? So here there's an important theory that we need to know. So remember they told us that A and B are independent, right? That's what we were told. We were told that A and B are independent. Okay, so if A and B are independent, okay, then A and B complement are also independent. So this is a theorem that I want you to know and master. Later on, we are going to see how to prove it. Again, if A and B are independent, then it means A complement and B are independent. Okay? And then the last one is A complement and B complement are also what? Independent. Okay. So in another separate video, I'm going to show you how you can prove these. But here, we just use them as the results. Okay. So if A and B are independent, then it means A and B complement are also independent. It also means A complement and B are independent. It also means A complement and B complement, they are also what? Independent. Okay. And when two events are independent, then their intersection will just be the same as multiplying their individual what? Probabilities. So this is the same as the probability of A multiplied by the probability of B complement. Okay, so this will just be equals to. So now the probability of B complement, we are going to use the complement rule. Okay, so the complement rule simply says that B complement, okay, let me not say that. So the complement rule simply says that the probability of B complement is the same as 1 minus the probability of the event B. Okay, so simply meaning that the probability of the event B happening plus the probability of the event B not happening should always be equals to 1. Okay, should always be equals to what? To 1. So it's the same as when you write a test. So when you write a test, okay, the marks that you're going to get in that text and the marks that you're not going to get in that text, they will all add up to what? To 100. That's the concept that we are trying to do here. So the probability of passing and the probability of failing a test that you write are always going to be adding up to what? To 1. Okay, so if the probability of passing a test is 0.7, then the probability of you not passing that test will just be what? 0.3. So the event, the probability of an event and the probability of its complement should always add up to what? To 1. Okay, that's where this formula comes from. Right, so it means here I can find the probability of B complement because I have the probability of B there. So it will be 1 minus C, 1 over what? 4. So this one, okay, for easy manipulations of fractions, this one here is the same as 4 over 4. Okay, 4 over 4 is the same as 1 minus 1 over 4. I just want to have the same denominators there. So meaning that what I'm going to have there is just a common denominator, and then I subtract whatever is on top. So that will just be 3. Okay, so probability of A is 2 over 5 multiplied by the probability of B complement, which is 3 over what? 4. So this will be 6 over, because this is 2 multiplied by this, 6, 5 multiplied by this, 20. 2 into 6, 3, 2 into 20, that would be 10. So here, this is the probability, okay, of A intersection what? B complement. So 3 over 10. Let's look at part C. Part C says find the probability of A union B. Okay, so here we're just going to use the sum rule of probabilities. So this is the same as probability of A plus the probability of B minus the probability of A intersection what? B. So the probability of A is 2 over 5 plus 1 over 4 minus the probability of A intersection B was this guy here, which is 1 over what? 10. So what is the common denominator there? Okay, what is the common denominator there? So the common denominator there will be 20. So 5 into 20, that will be 4, multiplied by the 2, 8, plus 4 into 20, that will be 5, multiplied by the 1, still remain with 5, minus 10 into 20, that will be 2, multiplied by the 1, that will be 2. So on top I have 8 plus 5 minus 2. So that will give me 11 divided by 20. Okay, so that is my probability of A union B. It's 11 over 20. All right, we are done with that one. We move on to part B. So part B now we're dealing with mutually exclusive events. So they're saying if A and B are mutually exclusive, okay, so remember the definition, if they are mutually exclusive, then it means A, okay, intersection B is equals to 0. So if A and B are mutually exclusive, find the probability of A union B. So this will just be the same as probability of A plus the probability of B minus the probability of A intersection B. But this probability here, since these events are now mutually exclusive, it's going to be 0. So this will just be the addition of this guy and that guy. So that will be 2 over 5 plus 1 over 4. So this will be, common denominator is 20. Okay, 5 into there, multiplied, 5 into 20, it's 4, multiplied by 2, 8, plus 4 into 20, that will be 5. Okay, 4 into 20, it's 5, multiplied by 1, that is 5. So this is just going to be 13 over what? 20. Okay, so for part B, number 1, probability of A union B is actually equals to 13 over what? 20. All right, so if you're enjoying this video, we'd like to let you know that we have more videos on our website, which is discretelearning.com. Okay, and these are the math courses that we offer. There's linear algebra, you can see it there. Uh, there are videos there and materials for financial mathematics. There's introduction to real analysis. There's probability and statistics. There's engineering mathematics. There's analytical geometry and calculus. And in all these courses, we are going to be providing, okay, past quiz solutions, past test solutions. We are going to be providing full tutorial sheet solutions, full assignment solutions, and final exam paper solutions. So all these are going to actually help you to pass any assessment that you may be given very easily. Okay, if you'd like to contact us, you can use this number here and this number, then you'll be through to us. All right, so here we are solving probability questions, right? So those questions are coming from tutorial sheets. So we have a lot of tutorial sheets available on our website or the mobile app. So we have tutorial sheet 1, which covers these concepts here. So if you like to learn about the sample space, the outcome, classical probability, you might want to register for that course on the website so that you can access all these videos to these tutorial sheet questions. So you can see tutorial sheet 1 has these videos, okay? Probability with cards, the dice, the coins, the events without the events involving without replacement, their compound experiments. All these questions have been solved and they'll help you to understand at your own time. Tutorial sheet 2 has questions on conditional probability, independence of events, like the one that we did in one of the videos, okay? Mutual exclusive events, all these Bayes theorem applications, law of total probability. These questions have been solved and they make it easy for you to understand. We also have tutorial sheet 3, okay, which is on standard distributions and the moment generating functions. So moment generating functions of all the distribution that you can think of, the questions are there solved in tutorial sheet 3, okay? Tutorial sheet 4 has continuous distributions and the joint distributions. So all these videos for questions that cover these concepts have been uploaded on the website, and you can access them at your own time, even in your blankets. Okay, so when I go back here, when I go to the PDFs here, so these are the tutorial sheets. So we have tutorial sheet 1 here. I showed you what is contained in tutorial sheet 1. So all these questions here are going to help us understand those concepts clearly. Okay, tutorial sheet 2, you can see again, this question is on independence events, exclusive events. All these questions here have been solved, and they are available on the website for you to watch and learn anytime. Tutorial sheet 3, it has different distributions. Okay, you can see all these questions here in tutorial sheet 3 have actually been solved, and they are available on the website. Tutorial sheet 4, all these questions have been solved and they're available on the website. Okay, and we'll also be uploading more questions, more tutorial sheets, as well as past papers like quizzes, okay, like tests, like a final exam papers. All these things here, quiz, tests, final exam papers, they're going to be available. And when you register with us, okay, when you're given a tutorial sheet, okay, we're going to provide a solution. So when you're given an assignment, we are also going to help with the assignment. Okay, so hurry, don't delay, head over to discretelearning.com and register. Okay, let's look at the last part of B. So the last part of B says, find the probability of A complement intersection B. Okay, find the probability of A complement intersection what? B. Okay, so how can we find the probability of A complement intersection B for mutually exclusive events? Okay, so there we are going to use a very nice theorem. Okay, we're going to use a very nice theorem. So I'll draw a picture just to give you an idea of whatever is happening. Okay, so I have two events, so we'll call them as sets. So I have set A and set B, right? Which are mutually exclusive. So this is my set A, and then that is my set B, right? Okay, so sometimes it's very helpful to draw diagrams like this. Okay, so this is my set A, and then this is my set B. Okay, so I'm finding the probability of A complement intersection B. Okay, finding the probability of A complement intersection B. So first of all, where is my A complement on this Venn diagram? Okay, my A complement is everything that is outside A. Okay, so I'll shade that part which is outside A with red. Okay, so everything that is outside A, that is my what? My A complement. Okay, everything that is outside A, that is my A complement. And then they're saying intersection B. So I'll shade B with green. So this is my set B now. Okay, so now, since we are looking for the intersection, okay, of A complement and B, I'm going to look for a part where I have both red and green lines. Okay, so you can see that that part where I have red and green lines is going to be this part where I'm tracing in blue. So this part here, now our tracing, so this part here, what is happening now? Okay, so this part here that I've traced in blue, that's the part where you can see both red lines and what? And the green lines, right? Okay, so that is A complement intersection B. That part there where it has the green lines and the red lines. So this part here, okay, this part here, that's where this guy is. So I'm just going to find this probability here, I'm just going to find another way to describe this part here, okay? Because it has been described as this, okay? But for me to simplify my calculations, I'm just going to find another way in which I can describe this part here. So you see that this part here, that has both the green lines and the red lines, is actually just a part of B, okay? It's just a part of set B, okay? Removing the what? Removing this part here. So you see this part that they've removed from set B is actually the part A intersection B. This part here, this is A intersection B. So they have just to get this part here, they've just said B minus A intersection B. That's what they've said. Okay, this is the part there. Okay, all right. So it means that A complement intersection B is also the same as B minus what? A intersection B. Okay, so I'm just going now to add a probability sign there and the probability sign there. That's all. So meaning that the probability of A complement intersection B is actually equals to the probability of B minus the probability of A intersection B. So yeah, so I hope you've gotten it how we've come up with this formula here. First, we shared what we were given, which is A complement intersection B, right? We found that that part, the A complement intersection B, was this part here, where the red lines and the green lines are appearing, this part here that has been traced in blue. Okay, and then to solve it, we just want to find another clever way in which we can describe this same region here. So how can we describe this same region here? This is just the set B here, but subtracting this part here, which is A intersection what B. This is where I got this formula there. Okay, so that's the formula that we're going to use in order to find that guy. And now remember that these are mutually exclusive events. So this one is equals to probability of B minus the probability of A intersection B. Okay, so now these are mutually exclusive events. So this guy is 0. So this part here is just the same as probability of what? B. And the probability of B is simply 1/4. Done. Okay, so you just have to know, the properties. Okay, if you know the properties, then it will be very easy for you to solve any type of question by using what? Manipulations. All right, let's move on to another question, which is this one here. Okay, so here they're saying events A and B are such that, okay, events A and B are such that the probability of A is equals to 4/7. The probability of A intersection B complement is equals to 1/3. And the probability of A given B is equals to what? 5/14. Okay, 5/14. So here I'm just going to say find the probability of A intersection B. So how am I going to find the probability of A intersection B? Okay, we're just going to use the trick that we used here. Okay, it will be the same. So I'll redraw this so just remember. So this is my A, right? And then this is my B. Okay, then this is the Venn diagram that I have. Okay, so the probability, okay, the probability of A, okay, let me write it here. Probability of A intersection B complement, this guy here can be described in another way. So here now, I'm shading the part which is outside A. So the part which is outside A is everything which is outside here, outside A. Okay. Let me just, okay, I'll show the lines. So this is the part that is outside A. Okay, you shade everything which is outside A like that. Okay, so this is my A. What? I shaded B complement. Okay, I shaded the A complement, but there's no A complement. Here there's A. Okay, anyway. Okay, let me just switch the letters there. It's no problem. I'll just say this is my B and then this is my A. Okay, so the part that I've shaded in black there is actually B complement. You can see these lines are not touching the set B. So that is a B complement, right? And then I want to intersect the B complement, this one, with the set A. So the set A, I'm now going to shade with the green. So this is my set A, inside the set A, this one here. Okay, so which part has both the green lines and the black lines? Okay, so it will be this part here. So this part here is the one that has the black lines, which were representing B complement, and then the green lines, which were representing A. So for me to solve this question easily, or to find this guy here, I'm just going to describe this part here that I've traced in blue in another way. So this part that I've traced in blue will be the same as it, okay? Probability of A, okay? This whole thing here, minus this part here, which will just be what? A intersection B. Okay, so to find this one, A intersection B, we're going to use this because this guy here has been given. So probability of A intersection B is this one. So that would be 1/3 is equals to probability of A, that is 4/7 minus the probability of A intersection B, the one that we are looking for. So this will just be, this one I'll take the other side. So probability of A intersection B is equals to, this is 4/7. This one goes to the other side, minus 1/3. Okay, so there we just have to subtract those. So the common denominator here will be 21. 21, 7 into 21, that will be 3, multiplied by 4, that will be 12, minus 3 into 21, that will be 7. 7 multiplied by 1, that will be 7. Okay, so this will just be equals to 12 minus 7, that will be 5 over what? 21. Okay, so probability of A intersection B is simply 5 over what? 21. Okay, and we found it using this simple trick that we are doing here. All right, so know this trick by heart. Let's look at the next one. So the next one says find the probability of B. Okay, find the probability of B. So this one is going to be very easy because I can use the conditional probability. So probability of A given B is equals to the probability of A intersection B divided by the probability of B. So probability of B will just be what? Okay, so I can cross multiply. So it will be probability of A given B multiplied by the probability of B is equals to the probability of A intersection B. So I want this, so I'll divide both sides by this guy. So I'll just remove probability of B divided by, is equals to probability of A intersection B divided by probability of A given B. So now the probability of A intersection B, we found it was 5/21. And then divided by the probability of A given B. Okay, probability of A given B is 5/14. So what is going to happen here is that to be 5/21, here, this guy is going to become a multiplication, right? Grade 1 stuff. This one goes up, this one comes down. So that would be 14 and then 5. So you see that this 5 and this 5 will cancel. So here there's 1 and 1. So 1 multiplied by this, okay? So probability of B just be equals to 1 multiplied by 14, that would be 14 divided by 21 multiplied by 1, that would be 21. Okay, so the answer there will simply be, what would be the answer there? Will simply be, okay, will simply be, okay, so we can actually reduce this. So I'll say 7 into 14, that would be 2. 7 into 21, that would be 3. So this is the final answer there. So the probability of B is actually 2/3. Right, done with that. We move to the next one. So here we are finding the probability of B given A. So this will be the same as probability of A intersection B by the conditional probability rule divided by the probability of A. So we have all these. So probability of A intersection B, that is 5/21, this one here. Then this divided by, I write it like this. Probability of A has been given in the question. So that is 4/7. So this will just be 5 over 21 multiplied by 7 over what? 4. Okay. So this will be, I can say 7 there, 1, 7 here, 3. So 5 multiplied by 1, I get 5 divided by 3 multiplied by 4. So there I'm going to get 12. Okay, so that would be the probability there to be 5 over what? 12. All right, so if you're enjoying this video, we'd like to let you know that we have more videos on our website, which is discretelearning.com. Okay, and these are the math courses that we offer. There's linear algebra, you can see it there. There are uh, there are videos there and materials for financial mathematics. There's introduction to real analysis. There's probability and statistics. There's engineering mathematics. There's analytical geometry and calculus. And in all these courses, we are going to be providing, okay, past quiz solutions, past test solutions. We are going to be providing full tutorial sheet solutions, full assignment solutions, and final exam paper solutions. So all these are going to actually help you to pass any assessment that you may be given very easily. Okay, if you like to contact us, you can use this number here and this number, then you'll be through to us. All right, so here we are solving probability questions, right? So those questions are coming from tutorial sheets. So we have a lot of tutorial sheets available on our website or the mobile app. So we have tutorial sheet 1, which covers these concepts here. So if you like to learn about the sample space, the outcome, classical probability, you might want to register for that course on the website so that you can access all these videos to these tutorial sheet questions. So you can see tutorial sheet 1 has these videos, okay? Probability with cards, the dice, the coins, the events without the events involving without replacement, they're there, compound experiments. All these questions have been solved and they'll help you to understand at your own time. Tutorial sheet 2 has questions on conditional probability, independence of events, like the one that we did in one of the videos, okay? Mutual exclusive events, all these Bayes theorem applications, law of total probability. These questions have been solved and they make it easy for you to understand. We also have tutorial sheet 3, okay, which is on standard distributions and the moment generating functions. So moment generating functions of all the distribution that you can think of, the questions are there solved in tutorial sheet 3, okay? Tutorial sheet 4 has continuous distributions and the joint distributions. So all these videos for questions that cover these concepts have been uploaded on the website and you can access them at your own time, even in your blankets. Okay, so when I go back here, when I go to the PDFs here, so these are the tutorial sheets. So we have tutorial sheet 1 here. I showed you what is contained in tutorial sheet 1. So all these questions here are going to help us understand those concepts clearly. Okay, tutorial sheet 2, you can see again, this question is on independence events, exclusive events. All these questions here have been solved and they are available on the website for you to watch and learn anytime. Tutorial sheet 3, it has different distributions. Okay, you can see all these questions here in tutorial sheet 3 have actually been solved and they are available on the website. Tutorial sheet 4, all these questions have been solved and they are available on the website, okay? And we'll also be uploading more questions, more tutorial sheets, as well as past papers like quizzes, okay, like tests, like a final exam papers, all these things here, quiz, tests, final exam papers, they're going to be available. And when you register with us, okay, when you're given a tutorial sheet, okay, we're going to provide a solution. So when you're given an assignment, we are also going to help with the assignment, okay? So hurry, don't delay, head over to discretelearning.com and register. So once you go on the website, okay, so attached in the description, there's a video that shows you how you can register. So once you register and then you go to our website, okay, you're going to see something like this. So let me log in into the account. So if you want to log in, you just click Start Learning there, and then you put your email there and the password. Then you say login. Okay, so once you're in, depending on the course that you've subscribed for anyway, so since this video is on questions on probability, I'm going to go to that same uh, folder for course for probability. So where is the folder for probability? I think I've passed it. Okay, so probability and statistics is there. So just click statistics and probability, and then you wait for the course to open. Okay, so you can see the course has opened. So there are summarized notes here. You can use them to study at your own time. There are statistical tables there that you can use. Here are tutorial sheets. There are the past quiz, test, and exam papers. Okay, so if you want to access the tutorial sheets, just open tutorial sheets folder there, and then it will open. So it will ask you probability or statistics. Okay, so depending on the course that you are currently taking, if it's probability, you click probability. So let's click it. Okay, so the folder is opening. So once it opens, there's a provision of video solutions, and we might upload written solutions as well. So if we upload written solutions, they'll be there. If we upload video solutions, they'll be here. So we just go video solutions here. Um, and then, yeah, so you can see tutorial sheet 1, tutorial sheet 2, tutorial sheet 3, tutorial sheet 4. All these are going to have full video solutions to all the tutorial sheets that we are going to, that we showed you. And then if you have, again, tutorial sheets that you've been given, just send them over. We're going to solve and upload them here so that you can access them anytime. Okay, so it's the same with the past papers. They're going to be in the past papers folder. So you can register and start learning at your own pace, at your own time, anywhere where you are. All right, so thank you so much for watching. This has been Tutor Pro Solutions. Until next time, always there for you.